Alright, so I'm going to go over your warm-up. So the first one was x plus 1 times x plus 5. Right, so if you remember, we go on the outside of the box, x plus 1, and x plus 5. And then we treat this like our multiplication table, right? We do x times x, which gives me x squared here. And then 1 times x would be 1x. And then 5 times x would be 5x. And 5 times 1, which would be 5. Right? And then I want to add everything up in the boxes. So I have x squared plus 1x plus 5x plus 5. Right? And you can combine my like terms, right? Right here, 1x and 5x. What does that combine to? 6x. Good. So this is x squared plus 6x plus 5. So x squared plus 6x plus 5. Okay, so let me put that in the next page real quick. So it's x squared plus 1x plus 5x plus 5, and that equals x squared plus 6x plus 5. Okay, so now we have m minus 4 times m plus 6. So same thing, m minus 4 times m plus 6. So again, multiplication, right? M times m would give me m squared. Negative 4 times m would be negative 4m. And then 6 times m would just be 6m. And then 6 times negative 4, 24, negative 24. Alright? And so then you add everything up. So m squared plus 6m minus 4m minus 24. Right? Again, I want to combine my like terms right here, the m's. So I end up with m squared plus 6 minus 4 would be 2m minus 24. Alright? Everybody remember this? This was on your test? Good. So if I fill this in, this is m squared plus 6m minus 4m minus 24, and it combines to m squared plus 2m minus 24. Alright, now last one, k minus 7 times k minus 3. So k minus 7 times k minus 3. So k times k is k squared. K times negative 7 is negative 7k. Negative 3 times k would be negative 3k. And then negative 3 times negative 7, positive 21. So then I want to add everything up. So k squared minus 7k minus 3k plus 21. So negative 7 minus 3. Remember, they're the same sign, right? This is a negative 7. This is a negative 3. When they're the same sign, you add them up. 7 plus 3 is 10. And then you keep the sign. We're keeping the negative. So it's negative 10k plus 21. And then don't forget the k squared at the beginning. Alright? So again, this was k squared minus 7k minus 3k plus 21. Alright? So, and we combined our like terms, and it was k squared minus 10k plus 21. Okay? So that was multiplying, right? We were multiplying binomials. That's how we started all of this, right? Then we multiplied and we ended up with a trinomial, right? Then we went to dividing, where we had a trinomial and then one of these, and we figured out what the other one was, right? We figured out what the other factor was. Well, now we're just going to start with this, and they're not going to give us the other one. We have to figure out both of the factors, okay? We have to figure out both of the factors, okay? So now we're going to go backwards completely, but they're only going to give me the answer, okay? So that we're going to be factoring trinomials now, okay? So, and to factor a trinomial, right, x squared plus bx plus c, you have to find two integers that multiply to c, right, that multiply to c, and add or subtract 2b. Okay, so we want two integers that multiply to c and add subtract to b. Okay, so here's an example. So I have x squared plus 7x plus 12, right? Okay, I need to find two integers that have a product of 12 and a sum or difference of 7. So c is my 12, right? So the 12 is the c right here. Does that make sense? That's what we're talking about here. They have to multiply to c, and then they have to add or subtract to 7, just a 7, right? Which is the b. Does that make sense? So I need two numbers. There's two specific numbers that I can multiply together and they give me 12, right? When I multiply them, they give me 12. But then when I add them, I get 7, okay? So that's two conditions they have to satisfy, okay? Now, there's many multiples of 12. There's 1 and 12, right? 1 times 12 is 12. What else? 2 times 6. 2 times 6 is 12, right? 3 times 4. 3, 6, 9, 12, right? And then it goes backwards, right? 4 and 3 and 6 and 2 and 12 and 1, right? So I can just stop here because these are all the same. They're just reversed. So these don't matter down here, okay? All I'm worried about is these two, okay? So then I need to add them together. So if I add 12 plus 1, I get 13. 6 plus 2 would give me 8, and 4 plus 3 would give me 7. Okay, so my two integers are 3 and 4. Okay, so the two integers are 3 and 4. Okay, now if you don't remember the multiples, okay, if you don't remember how to get this, there's a way on Desmos. Okay, so the way you figure out the multiples, if you forget how to do it, so you do whatever c is, which for our example was 12. Right? And then you're going to divide it by x. Okay? But it gives you the graph, and I don't really care about the graph. I want the table. Do you remember how to get to the table?
With settings.
Settings, okay. And then you click the table, right? That gives me the table. Right? So here are your factors. Right now, I'm not worried about negatives. I just want the positives, okay? So 2 and 6, 3 and 4, 4 and 3, and then it starts to repeat itself, right? 4 and 3, 6 and 2, okay? And then there's some with decimals. I don't want any of the decimal ones, okay? I just want the whole numbers, okay? Only the whole numbers. So that's how you get them if you forget, okay? So let's go back over here. So I figured out that it was 3 and 4, because when I add 3 and 4 together, I get 7, okay? So now I'm going to draw my box, okay? And we talked about when we were dividing what stays the same. The x squared, what does it go? The top left?
The first and last. Bottom right. Yeah, bottom one is good.
The bottom one is the bottom right.
Yeah, right? Bottom right.
So this one right here is a 12. Okay? So those two stay the same, right? But then I was like, okay, I can't fill these two in because I don't know, it could be any combination, right? But now, since we did this right here, since we figured out our multiples right here, and that what they added up to, now I can put them in here. So my 3 and 4 is what's going to go inside the box. Okay? And it's going to be 3x and 4x. This is looking ugly. Okay? So now I can figure out what the outside is using everything on the inside. So x squared, what times what gives me x squared? X times x, right? Okay, and then what times 3x, what times x gives me 3x? 3. So I want what times x gives me 3x. And you said it's 3. Good. Positive 3. Good. Okay? And then now, what times x gives me 4x? 4. Positive 4. Okay? And so now if you check, positive 3 times positive 4 would be positive 12. So that means my factors are x plus 3 times x plus 4. Okay. And again, it doesn't matter where you put, you could have put the 3x here and the 4x here, you're still going to end up with the same answer. Okay, so let's try number 1. Okay, so number 1, my C is 20. Okay, so I'm going to start off by drawing the box to get it over with. Okay, so I'm going to draw the box. And so what stays? What do I have to fill it with? The n squared and the 20, right? So this here is n squared, and here is a 20. And so I need to figure out what goes here. And how do I figure that out?
What two integers have product of 20 or in the sum or difference?
Good. So I need two integers that multiply to 20 and then add or subtract to 9. Okay? When they're both positive, we want positives. Okay? So I want 20 divided by x. Right? 20 divided by x. So I'm going to settings. And I'm doing the table. Okay? So I have 1 and 20. What's 1 plus 20? 21. What did I want them to add up to? 9. Okay. Alright. Let's do 2 and 10. 2 plus 10 is 12. Oh, that's a decimal. I can't use that one. 4 plus 5. 9. And 4 times 5 is 20. Okay. So 4 and 5 are my two integers that I want to fill this with. Okay. So this is 4n and 5n. Okay? Does that make sense? Okay? So then, what times what gives me n squared? N times n, right? N times n gives me n squared. And then what times n gives me 4n? Positive 4. Okay? And then what times n gives me 5n? Positive 5. Now check it. 4 times 5 is 20. So I'm good. So that means my two factors are n plus 4 times n plus 5. N plus 5. Okay? Try number 2. Try number 2 out. Okay, number 2, let's go over it. So you drew your box, right? Okay. Okay, and then what'd you fill it with?
Top right, no, top left, w squared.
W squared.
Bottom right.
18, good. So w squared and 18, those two stay the same. Right? So now, what do you need to do?
Find the two integers that have a product of 18 and sum or difference.
So you need two numbers that add up, that multiply to 18 and add up to 9. So again, you can use Desmos to help you if you forget what your multiples are. Right? So 18 divided by x, right? And then you want to check your table. Okay, so my possibilities are 1 and 18, but 1 plus 18 is 19. Then 2 plus 9, 11. 3 plus 6, 3 plus 6 is 9, and that's exactly what we are looking for right here. So my two integers are 3w and 6w. Right? And again, it doesn't matter. You could have put the 3 down here and the 6 up here. You're still going to get the same answer. Okay? So then, what times what gives me w squared? W times W. And what times W gives me 3W? Positive 3. And what times W gives me 6W? Positive 6. Right? So then, my answer is W plus 3 times W plus 6. Alright, it's kind of hard to see there. Just understand. This is W plus 3 times W plus 6. Okay? Does this make sense? Okay? So, I don't want to do these. I just want to see what the factors would be. Okay? So, 24. So, 24, you're going to do 24 divided by X. Right? Change to the table. Okay? So, there are my factors. And I want them to add up to 10. Okay? So, 1 plus 24 is 25. 2 plus 12, 14. 8 plus 3, 8, 9, 10, 11. 4 plus 6, that's 10. So my two factors would be 4 and 6. Does that make sense? Okay, 1. What times what gives me 1? 1, right? What's 1 plus 1? 2. So here your integers would be 1 and 1. Okay? Does this make sense? Alright, let's go to set 2. So now we have negative 18. Okay? So I'm going to draw my box. Okay? So what stays the same?
The n squared.
N squared. And then negative 18. Okay? So now I need two factors that multiply to what? Negative 18. And what do they have to add up to?
3.
Positive 3, right? Okay? So then, I go to my Desmos. So now I have negative 18, right? Divided by X. Okay? And now I'm checking my table. Okay? So 1 plus negative 18. What would that be? Let's check. 1 plus negative 18 would be negative 17. Okay? And then, so a good trick here. 1 plus negative 18 is negative 17, right? I can switch the signs. I can do negative 1 plus 18, and I get positive 17. Okay? So, if you switch the signs, you're going to keep the same number, the sign changes. Okay? So, let's check 2 and negative 9. 2 plus negative 9. I get negative 7. I don't want a 7. What do I want?
3.
I want a 3. Some sort of 3. Okay? So let me delete these because these are wrong. Now let me check the bottom ones of these. So, what is 3? 3 and negative 6. So 3 plus negative 6 would be negative 3. But what do I want? Positive 3, right? This is positive 3. So what do I have to do? Change the signs, right? So that means the 3 is going to be negative and the 6 is positive. So now it's positive 3. Does that make sense? Okay, so you're just adding across. Okay? So, negative 3 plus 6. Another way to think about it is, if you just put positive 18, right? Okay, positive 18. So, if positive 18, think of it like if you're subtracting. Okay? So, 1 minus 18, when it's negative, you want to do subtraction. 1 minus 18 would be negative 17. 2 minus 9 would be negative 7. 3 minus 6 would be negative 3. But I want positive 3, so then we're going to do 6 minus 3. So that means the 6 is positive, the 3 is negative. Okay? So it's positive 6 and negative 3. So now I'm going to fill those in. Positive 6n and negative 3n. Okay? Just to make negative. And we use this. It's positive 3, so it's negative 3 and positive 6. Okay? So, what times what gives me n squared? N times n. Now, what times n gives me positive 6n? Positive 6, right? Now, what times n gives me negative 3n? Negative 3, right? So this becomes n plus 6 times n minus 3. And that is my answer. Okay? So the negatives is where it starts to get a little confusing, but if you stick to the whole adding together and use decimals, okay? It can add up stuff. Okay, it adds stuff for you. Okay, so use that. So try number 6. Try number 6 out. Okay. Number 6, x squared plus 2x minus 8. So draw my box. All right. So what stays? X squared and negative 8. So I need two factors of negative 8 that add up to 2. So let me go to my Desmos and check them out. Exit all this. So negative 8 divided by 2. Negative 8 divided by x, sorry. Divided by x. Okay. So then I'm going to change this to a table. So I have 1 and negative 8. So 1 plus negative 8 would be 1 plus negative 8 would be negative 7. Get a decimal there. So 2 plus negative 4 would be negative 2. And I want positive 2, right? I want positive 2, so I'm going to switch the signs. Right? This gave me negative 2, so I'm going to do negative 2 plus positive 4, or just plus 4. So that's positive 2. So that means my multiples or my factors are negative 2x and positive 4x. Right? So then what times what gives me x squared? X times x. What times x gives me negative 2x? Negative 2. What times x gives me 4x? Positive 4. So my answer would be x minus 2 times x plus 4. Okay, does that make sense? Questions? Alright, let's go to the back. Okay, number 9. Now they're both negative, right? So I have a squared minus 2a minus 3. 3 is a prime number, right? Remember 3, the only thing I can multiply 3 by, divide 3 by is 1 and itself, right? I can't divide 3 by 2 because then I get a decimal. So my factors, my only factors really are 1 and 3. Okay, so I'm going to draw my box. Okay, so a squared stays, right? And then it's negative 3. Okay, so again, just to remind you, because 3 is prime. If you know your prime numbers, then the only thing that can multiply then is itself. So negative 3 divided by x. Change this to a table. And if you check all the other ones, they're all decimals. Okay, the only other one is 3 and negative 1 and negative 1 and 3. So negative 1 plus 3 would be what? What's negative 1 plus 3? Negative 2. 1 plus 3 is no, I think it's 1 plus negative 3. 1 plus negative 3 is negative 2. And that's what I want, negative 2, right? So it's negative 3a and positive 1a, right? Does that make sense? If it was positive 2, then it'd be the switch, right? It would be negative 1 and positive 3. Alright, so then we got to figure out the outside. So what times what gives me a squared? A times a. And then this would be negative 3. And then what times a gives me 1a? 1. Good. So my answer answer is a minus 3 times a plus 1. That makes sense? So if you see, there's still like a pattern going on. We're still doing the same thing. Okay. So try the next one. Try number 10. Okay, what did y'all get for number 10? You should have gotten x minus 10 times x plus 3. If you got that, then you did good. Alright? And again, to check your answers, you put this in Desmos, and then this graph should match as well. Okay? Okay, so set number 4. So same thing. I want to draw my box. Okay? So the first thing that stays is x squared. Then it's 24. Right? So I need two factors of 24 that add up to negative 11. So 24 divided by x, right? And I'm checking for the table. So 1 and 24, 1 plus 24 is 25. 2 plus 12 is what? 14. 3 plus 8. That's positive 11, right? 3 plus 8 is positive 11. But we want what? We want negative 11, right? So remember we talked about switching the signs, right? Well, if I switch the signs of both of these numbers, I'm going to make them both what? They're both going to be negative, right? So negative 3 plus negative 8 gives me negative 11. Okay? So this is negative 3x and negative 8x. Okay, so then we go back to it. X, what times what gives me x squared? X times x, right? And then what times x gives me negative 3x? Negative 3. And then what times x gives me negative 8x? Negative 8. And negative 8 times negative 3 is positive 24. So, real quick. So this would be x minus 3 times x minus 8. Okay? So, if you notice, all these sets have been different. So the first set on the front page was, they were both positive, right? This is a positive and this is a positive. And if you notice our answers, they're both positive as well. So, if you get a trinomial where they're both positive, then your factors are going to be both positive. Okay? Look at set 2. I have a positive, then a negative, right? A positive, then a negative. So my B, when the B is positive and the C is negative, you want the bigger number to be the positive one. So my bigger factor here was 6, right? So between 6 and 3, I wanted 6 to be positive. So if the positive is first, then you want the bigger one to be positive. Now let's go to set 3. Here they're both negative, right? If they're both negative, you want the bigger number to be negative now. Okay, so if it's a negative and then a negative, you want the bigger number to be negative. Now here I have a negative then a positive. This is different. Okay, if they're negative and then a positive, then I want both of my factors to be negative. Okay, so that's kind of a trick, but if you stick to the whole adding them on Desmos, then you'll see. You'll learn eventually. Okay, so now real quick, look at number 23. So now what we did on Friday was factor out the GCF. Remember we did the GCF on Desmos? We're going to start doing this here now too. So for 23, if I type GCF, right, and then I have 4, 12, and 8. So this would be a 4, 12, 8. So my greatest common factor is 4. So I'm going to factor out a 4. I divide all of these by 4. And this now becomes 4 times k squared, because the 4's cancel out. 12 divided by 4 is 3k. And then 8 divided by 4 is 2. And so now you're going to factor this out, just like we did above. Alright?